In this video, I'm going to be showing you a solution to this tricky limits question from AP Calculus. So we have to find the limit of this expression as x goes to 1. Now, the solution is as follows. So, first thing, what I like to always try is to put the value directly into the value of x directly into the equation and see if we get a valid answer. So if we try that here, this becomes limit x tends to 1, x3 plus 1 divided by x minus 1 becomes 1 cubed plus 1 divided by 1 minus 1. This is 2 divided by 0. Now, 2 divided by 0 makes no sense. You cannot divide a number by 0. It makes no sense. So this is not a valid answer. So we have to try something different. Direct substitution would not work. This would not work. Okay, so now what we could try is the concept of one-sided limits. One-sided limits. Now, what does that mean? We are going to calculate the limit of this expression firstly as x goes to 1 from the left hand side of x, which is denoted by negative. Then we're also going to calculate the limit of this expression as x goes to 1 from the right hand side of 1. If these two values, if these two expressions, if these two give the same value, then this limit will be that value. But if these two values are different, then the limit does not exist. You see? Then the limit does not exist. That is the beauty of one-sided limits. So we can calculate from the left-hand side of the value of x and from the right-hand side of the value of x. If they give the same answer, then we'll say that the limit at that value is the answer. That's the answer to the question. But if they give different values, then the limit at that particular value of 1, in this case 1, does not exist. Okay, so that is the concept of one-sided limits. Now, the x goes to 1 from left-hand side of 1, that's what this negative represents. It means values less than 1 but are very close to 1. So we are looking at 0.9, 0.95, 0.999999. You see, values that are less than 1 but very close to 1. Now this one means values that are greater than 1 but very close to 1. So we are looking at 1.1, 1.01 and things like that. They are very close to 1 but it is greater than 1, you see. And then of course this is less than 1. So let's start from this one. So if you put a value of, for example, now 0.9 here, 0.9 here, just as an example, 0.9 cubed plus 1 divided by 0.9 minus 1. You are going to get a number here. You're going to get a valid value. You're going to get a valid value here. You see, valid value. So that means you would always have a value here, and it will be negative because the denominator is negative. All right, because 0.9 minus 1 is negative 0.1. So the answer here will always be negative. So all the answers here will be negative going up onto negative infinity. All right, negative infinity. So you would have negatives up onto negative infinity. Negative infinity is a value, a large value, but it's negative. All right. Now for this other one, let's say we put, for example, let me make this one here like this so that you know this was just an example, because you could put any other value. 0.95, 0.915 could also work. Now values greater than 1 for very close to 1. Let's think of values like maybe 1.1. If you put a value of 1.1 here, let me put this in brackets now. 1.1 cubed plus 1 divided by 1.1 minus 1. You're also going to get a value here. You're going to get a value here because 1.1 minus 1 is 0.1. Then this is a valid value. When you divide, it's going to be positive. So you're going to have positive values here up onto positive infinity. All right. So positive values for this guy, negative values from this guy. So for the left hand side limit of this expression, you're going to have negative values up onto negative infinity. For this guy, you're going to have positive values, positive infinity. But you see that the two values are not the same. One is negative and one is positive. And when you have two different values for one-sided limits, then the limit at that particular value does not exist. So the answer to this question would be non-existent, because the two one-sided limits do not give the same value. And that is how you solve this tricky limit question from AP Calculus. If you found value from this video, please make sure you subscribe so that you can get more videos like this teaching you about limits and other topics in AP Calculus. Make sure you also like this video. I will see you in the next one. Thank you.